You check the time 40 times a day without thinking about it. A glance at your phone. A clock on the wall. A number in the corner of a screen. It's automatic, invisible, almost boring. For most of human history, it wasn't automatic at all. It was one of the hardest problems your ancestors ever tried to solve. Imagine waking up with no clock, no calendar, and no way to know if you're late for anything, because late doesn't exist yet as an idea. And yet, somehow, ancient humans still needed to know things. When to plant, when to migrate, when the flood would come, when a ritual had to happen. So how do you measure something invisible, something you can't hold, weigh or see, using nothing but rocks, shadows, and the sky? The answer turns out to be some of the strangest, most inventive engineering our species has ever produced. Let's start with the sky, because that's where almost everyone started. Archaeologist Alexander Marshak spent years studying a 20,000-year-old piece of bone covered in tiny, seemingly random notches. Most researchers had assumed it was decoration. Marshak noticed something else. The notches followed a pattern that matched the phases of the moon, waxing, full, waning, new, repeating, in a cycle of roughly 29 to 30 marks. If he was right, this wasn't art. It was one of the oldest known calendars, carved by hand, one lunar cycle at a time. That single insight reframes everything. Long before writing, before agriculture, before permanent settlements, at least some ancient humans were already tracking time with enough precision to notice and record an astronomical cycle. Not because they were bored, because knowing when the moon would be full again might mean the difference between finding your way back to camp in the dark or not. But the moon is only part of the story. The real challenge was the sun, and it produced some genuinely bizarre solutions. At Stonehenge, built in stages, starting around 3000 BCE, the massive stones aren't just arranged randomly. On the summer solstice, the sun rises in near-perfect alignment with the site's main axis. Archaeologist Mike Parker Pearson, who led major excavations there, argues the monument likely functioned as a kind of massive seasonal marker, a tool built from stones that could weigh over 25 tons, just to know exactly when the year had turned. Think about the sheer scale of that undertaking. People dragged multi-ton stones for miles, shaped them by hand, and positioned them with enough precision to catch a single sunrise once a year, for a purpose most of them wouldn't personally see repeat more than a handful of times in their lives. That's not a coincidence. That's an entire community treating the measurement of time as important enough to justify one of the largest construction projects of the ancient world. And it wasn't just enormous stone monuments. Some solutions were almost absurdly small and clever by comparison. In ancient Egypt, sundials appear as early as 1500 BCE, using nothing more than a stick called a gnomon and its moving shadow to divide daylight into hours. But nighttime posed a problem sundials couldn't solve. So Egyptian timekeepers invented water clocks, called clepsydra, vessels with a small hole that let water drip out at a steady rate, with markings inside showing how much time had passed. Pour water in at sunset, and by watching the water level drop against the markings, you could estimate the hour, even in complete darkness. Here's where it gets strange. Water clocks had a hidden flaw nobody solved for centuries. Water drips slower when there's less pressure behind it, meaning a nearly empty vessel drips more slowly than a full one. Egyptian engineers responded by shaping some clepsydra with slightly conical inner walls, specifically calculated so the changing width would compensate for the changing pressure, keeping the drip rate roughly constant. That's not folkcraft. That's applied physics, worked out through trial and error, roughly 3,000 years before anyone had a formal theory of fluid dynamics to explain why it worked. Other cultures solved the same problem with fire instead of water. In ancient China, incense clocks burned specially shaped sticks or coiled ropes of incense at a predictable rate, sometimes with small metal balls tied at intervals along the length. As the incense burned down to each knot, the ball would drop into a metal tray below, producing an audible chime. You could set what was essentially an alarm clock using nothing but scent and gravity, with no moving parts and no water at all. So let's reconstruct a single day using these tools together. You wake before dawn in a river valley settlement. Outside, a water clock from the previous night sits nearly empty, its final markings telling the household elder roughly how many hours remain before sunrise. As the sun climbs, a sundial's shadow shortens, marking the hours toward midday, when farmers know it's time to rest before the heat peaks. That evening, an incense stick is lit indoors, its knotted cord slowly burning down, so that hours later, a small metal ball drops with a soft chime, signaling it's time to check on a simmering pot or wake for a scheduled watch. Every one of these systems requires almost no modern materials, just careful observation, patient testing, and a genuine cultural investment in knowing exactly where you stood inside an invisible thing called time. Here's the counterintuitive twist. You might assume ancient timekeeping was primitive because it lacked our precision. But precision was never really the point, at least not early on. Anthropologist Barbara Adam, who studies human relationships with time across cultures, argues that most ancient societies didn't fracture time into rigid, uniform units at all. Hours weren't fixed 60-minute blocks. Not in many sundial systems, hours simply meant 1/12 of however long daylight lasted that day, so an hour in summer was noticeably longer than an hour in winter. Time bent around the natural world, rather than the natural world being forced to bend around time. That's almost the exact opposite of how you live now. Your hour is identical at 3 p.m. in December and 3 p.m. in June, locked at exactly 60 minutes by mechanical and digital precision, completely detached from the sun, the season, or anything happening outside your window. Ancient timekeeping asked, "What is the world doing right now?" Modern timekeeping asks, "What does the clock say?" and expects the world to comply. There's a reason this sip happened. Once mechanical clocks appeared in medieval Europe, work, worship, and daily schedules increasingly organized themselves around a fixed external measurement rather than a lived, seasonal rhythm. It made coordination across large groups of people dramatically easier. It also, arguably, disconnected daily life from the very sky and seasons that first taught humans how to measure time in the first place. Now think about your own relationship with the clock. The alarm that yanks you awake regardless of sunrise. The meeting scheduled for exactly 2000 p.m., whether or not your body or the daylight agrees. None of that pressure existed for the person carving moon phases into a bone 20,000 years ago, or the engineer calculating the exact taper of a water clock's inner wall. They weren't trying to beat the clock. They were simply trying to notice what the sky was already telling them, then find a clever enough way to remember it. So the next time you glance at your phone to check the time, remember what that small, automatic gesture actually descends from: a hand-carved, bone-tracking moonlight, a shadow crawling across sand, water dripping through a carefully shaped hole, incense burning toward a small metal ball. The tools have changed almost beyond recognition. The impulse behind them, the need to hold on to something as slippery and invisible as time itself, hasn't changed at all.